In this video, I'll explain how to graph the polar curve known as a rose, which proves once and for all that mathematicians would make lousy botanists because this curve won't look anything like a rose, but it does look like a flower. So we'll make a picture here by considering the sinusoid y equals 4 cosine 6x on the left and using it to graph r equals 4 cosine 6 theta. Obviously, our amplitude's 4 and our frequency is 6. So I can work out that my period is 60 degrees, which is really important. Also, a quarter of the period is going to be 15 degrees, which you'll see is also really, really important. When I go and I make my sinusoid, I graph that first quarter of a period when cosine drops from its maximum to its midline. You'll see that that corresponds to a polar curve going from the point 40 into the pole, since if you hit the x-axis, you're at the pole. As I graph the next quarter of a period, I move down to this coordinate with a negative radius, -4, 30 degrees. And be careful graphing those negative radii. That's out here in the third quadrant. So I graph the next little piece of my polar curve. And then you can see in the next quarter of a period, we'll travel back to the pole. And that means we'll complete our first petal, because every time you go to the x-axis, you go to the pole. Next, I move out to a coordinate of 4, 60 degrees. And that point is easy to find on your polar graph. It's right about there. Make your next little piece and then come back to the pole again and you graph another petal. And this is how it's done with a rose, where you graph one petal at a time. Be careful with negative radii like this one. It's a -4 at 90 degrees, which is actually down there at an angle of 270. So the yellow petal should be down, not up. And then next I visit the coordinate 4, 120, which is out there at quadrant 2. So we graph the purple petal. And then next, we graph a petal that goes out to -150 degrees, which is actually in quadrant 4 because it's 150 degrees from the negative x-axis. Then our orange petal, back to a positive radius at 180, which of course is out to the left. And then we do another negative radius at 210 degrees. So 210 from the negative x-axis is going to be the same as 30 degrees from the positive x-axis. I'll graph this pink petal out here. And next we'll visit the coordinate 240, 4, 240, which is down there in quadrant 3. And we graph the green petal. And then we visit another negative radius at 270 degrees, which is positive 90 up there. And almost done. You can see the flowers kind of taking its shape. Right here at 300 degrees with a positive radius of 4. Graph a petal there in that empty spot in quadrant 4. And one last petal should do it. It's a radius of -4 and an angle of 330. So to graph 330 degrees from the negative x, you have to go all the way around, almost a full rotation, bringing you all the way back into quadrant 2. And that blue petal will just about complete the picture. The last quarter period, of course, is going to take you back to the point where you started, which is generally true of these polar curves. So we complete the red petal right there at the end. And what we've made is a 12-petal rose. So I hope this video helps you graph all the different roses that you see in the exploration. Maybe even gets you thinking about how you could graph a 6-petal rose, which is one of the bonus problems. So hope you enjoyed it. Thanks. If you're wondering why the video is still going on, I'm just practicing for animals and adjectives by drawing a teeny tiny bee.